Okay, so today's topic start with attacking reagents. So you know what are attacking reagents?
That attack that try to react with molecules that have a specific type of charge or in specific conditions.
Yes. So we have like electrophiles, nucleophiles, even amphiphiles. So what are electrophiles? As the name suggests, electrophile means electron attracting species.
Yes.
Means they are electron deficient. So either, yes, it is already written here, electron deficient means they are either positively charged or they are neutral. But if they are neutral, they should be electron deficient. And therefore, they attack on the site of high electron density. They will attack on the site where electron density is high. So electrophiles, they have incomplete outer shells and are also Lewis acids. They are electron acceptor. They are electron pair acceptors. For example, we have NO2 positive, anything X positive, Cl positive, SO3H positive, C6H5 N2 means anything which has a positive charge. R positive, RCO positive, neutral, you know, BF3, it is electron deficient, AlCl3, electron deficient, FeCl3, even SiCl4. Now, sometimes we are confused with SiCl4. Reason being in SiCl4, you know, silicon is attached to 4 chlorines.
Yes.
So it seems like it has complete octet.
Yes.
So how do it is electron deficient? So why it is electron deficient? Because it has yes, it has vacant d orbital. That's why.
Does the same reason follow for aluminum and iron?
Yes, same reason, because they have either incomplete d orbital or vacant d orbital.
Then why
Zn
Zn has D10 configuration?
has a d10 configuration, that you know, but at the same time, you know, when you have Zn attached to chlorines, electron density is withdrawn from chlorine, from zinc, and that's why it becomes somewhat electron deficient.
Understood.
Same is the case with SO3. You know, in SO3, if you look at SO3, it has configuration like this.
Yes.
Or if we form coordinate bonds, even sulfur has total valence electrons 6, and it becomes 12.
Yes.
Even same, because whenever there is a pi bond and pi bond is attached to more electronegative atom, it makes sulfur electron deficient. Same is the case with CO2. You know, it is like this.
Yes.
So carbon get partial positive, here sulfur gets partial positive, and that's why they are electron deficient and they behave as electrophiles.
Understood.
This is well known. What is this? CCl2.
Carbene, sir.
Yes, it is dichlorocarbene.
Polyhalogen compound.
Yes, and it is used as a reagent in, it is a Raymond-Diamond reaction.
Of benzaldehyde.
Yes, it is used as a electrophile in Raymond-Diamond reaction.
Yes.
Even free radicals are used as electrophiles because they are also electron deficient, because it is deficient of one electron. Okay, so this is all about electrophiles, and at the same time benzene ring undergoes electrophilic substitution reactions.
Yes.
Or sometime we can write it as SC reaction. So why electrophile, why it is undergoing electrophilic substitution reactions rather than addition reaction in spite of high degree of unsaturation? Because there is a pi bond.
Yes.
So if we have propene, ethene, let us say, and on catalytic hydrogenation, we get ethane.
Yes.
So whenever there is a pi bond, there is a bright chance of addition reaction.
Yes.
But in benzene, there are 6 pi electrons.
Yes.
In spite of the presence of high degree of unsaturation, it undergoes electrophilic substitution reaction rather than addition. Why is it so?
So to maintain
Yes, to retain its aromatic character. To retain its aromatic character, it undergoes electrophilic substitution reaction, because if it undergoes addition reaction, it undergoes addition reaction under vigorous conditions.
yes.
But if it undergoes addition reaction, its aromaticity is destroyed.
Yes.
That's why to retain its aromatic character, it undergoes electrophilic substitution reactions, and common electrophilic substitution reaction, always keep in mind, and they will do their job in all the compounds whenever there is a benzene ring. So whenever we have a benzene ring, it undergoes chlorination
Yes.
in the presence of anhydrous
Yes.
AlCl3 or anhydrous FeCl3, even sometime BF3, any Lewis acid. Anhydrous AlCl3 is a Lewis acid. So what will happen? This Cl-Cl bond, when come in contact with AlCl3, AlCl3 is electron deficient.
Yes.
So this electron deficient AlCl3, that will attract chlorine with its electron pairs.
Yes.
So, chlorine is non-polar,
Yes.
but in the presence of AlCl3, it gets polarized, and on polarization, this Cl-Cl bond starts breaking. Yes, and AlCl3 start attaching to it. It can change into Cl positive and AlCl4 negative, and this Cl positive is electrophile. So in chlorination, bromination, this X positive is a is an electrophile, and that will attack and we get chlorobenzene. So this is chlorination. In bromination there is, yes, in bromination there is Br2 and FeBr3. In addition to that, there is a formation of HCl. In case of bromination, we use FeBr3, so we get bromobenzene along with HBr. But in iodination, we should use some oxidizing agent like HgO. We can use. Why? Because Hi is a strong reducing agent. It is a reducing agent. So this reaction becomes reversible. So in this case, we have to use some oxidizing agent so that as soon as this Hi is formed, it should be removed from the reaction mixture. Okay, so that's all about this reaction. Then come to nitration. In nitration, benzene is react with HNO3 and H2SO4, concentrated HNO3 and concentrated H2SO4, and we get nitrobenzene. So in this case, what is the nature of this mixture is called nitrating mixture. Mixture of concentrated HNO3 plus concentrated H2SO4. This is called nitrating mixture. And in this nitrating mixture, tell me what is the nature of HNO3? Is it an acid or base?
It's a base.
So keep in mind that whenever HNO3, otherwise if they are studied alone, HNO3 as well as H2SO4 both are strong acids. But when both are present together, then HNO3 will accept H plus ion from H2SO4 and we get this type of product, and then this protonated nitric acid that will give H2O along with NO2 positive. And therefore keep in mind that this NO2 positive is an electrophile in nitration. Sometimes there is simple question, which electrophile is used in nitration. So NO2 positive is electrophile used in nitration. Now in sulfonation, so in sulfonation, benzene react with concentrated H2SO4. So in this case, there is self ionization. Two H2SO4 react together and we get this type of product. and then water is removed and we get SO3H positive, because H2O is a very good leaving group, H2O positive.
Yes.
So SO3H or SO3 is used as electrophile in sulfonation, and we get benzene sulfonic acid. So see, first halogenation, chlorination, bromination main, then there is sulfonation, then nitration, and next is Friedel-Crafts reactions. Friedel-Crafts,
Alkylation and acylation.
Friedel-Crafts alkylation. So in Friedel-Crafts alkylation, benzene react with, let us say, chloromethane, and we have again catalyst as anhydrous AlCl3.
Yes.
So here Cl already it is positive, carbon gets Cl is negative and carbon positive. So it react with AlCl3. AlCl3 get this Cl negative, and therefore we get carbocation along with AlCl4 negative, and therefore there is a formation of a methyl benzene that is called toluene. Now in this case, maybe question is like this. Let us say we have chloropropane, one chloropropane in the presence of anhydrous AlCl3. So what is the product form? Tell me. In this case, what is the major product?
Propyl benzene, sir.
So see, in this case, you know,
Okay, sir, I got it, I think. We'll get isopropyl benzene.
yes. So first of all, Cl negative ion is removed.
Yes.
Whenever the reaction is like the formation of carbocation takes place,
We need to check for shifting of carbon.
yes, we need to form most stable carbocation first,
Yes.
and then it will attack. But if it is a free radical reaction, then there is no rearrangement.
Okay.
Only in case of carbocation, we have to look for a most stable carbocation. So see, this is primary carbocation.
Yes.
So this primary carbocation and neighborhood carbon is secondary.
Yes.
So this hydride 1,2 hydride shift take place. One to hydride shift takes place, and we get more stable carbocation.
Yes.
This is secondary carbocation, or we can say isopropyl carbocation, and that's why major product formed is
Isopropyl.
isopropyl benzene, and isopropyl benzene is also known as cumene.
Okay.
There is a cumene process for the formation of
Benzoic acid.
phenol.
Phenol.
Cumene process is used for the formation of a phenol. That we will do later on.
So we react this with KMnO4 to get benzoic acid booster.
Yes, yes. With KMnO4, any alkyl group,
Yes.
it turn into benzoic acid.
So as long as it has a hydrogen.
Yes. Okay. Now, Fiddlecraft acylation. Okay. So in Fiddlecraft acylations, benzene react with acetyl chloride,
Yes.
again in the presence of anhydrous AlCl3.
Yes. So we can also use anhydride for this process, right?
Yes, anhydride can be used. So this is, but as actually acid chloride is more reactive
Yes.
in the acid derivatives, so it is better to use acid chloride.
Yes, sir, but I wanted to know how the reaction mechanism would look like for acetic anhydride.
Okay. So in this case, we get this product, and this is called
Aceto.
this is called acetophenone.
Yes.
So if we have acid anhydride, instead of Lewis acid, we can use acid, simple H plus ion. So that H plus ion will attack here,
Okay.
and that will give carboxylic acid
Yes.
along with CH3CO, and we get again acetophenone along with acid.
Okay.
So these are 5 reactions which are most common for any benzene. First one is chlorination or halogenation.
Yes.
Second one is nitration. Third one is sulfonation. Fourth one is Fiddlecraft alkylation. Fifth one is Fiddlecraft acylation. So these are the 5 reactions. Whenever there is a benzene ring, these reactions must be there in the chemical properties.
Okay.
So if we have benzene, methyl benzene, acetophenone.
Yes.
So if we compare their reactivity towards electrophilic substitution reaction, what is the order of reactivity? if we compare the reactivity order.
Yes.
So what is the order of reactivity? Actually, methyl group is
Electron withdrawing, electron donating.
methyl group has electron donating effect by hyperconjugation and plus I effect.
Yes.
That's why it will increase the electron density on the benzene ring. And if it will increase the electron density on the benzene ring by hyperconjugation, it is always at ortho and para position. So electron density particularly increased at ortho and para, but overall on the ring electron density increases with respect to as compared to benzene itself, and therefore toluene, this methyl benzene, is more reactive than benzene. So that means second compound is more reactive than first compound. Now come to acetophenone. So tell me, in acetophenone,
Minus R effect.
so it has minus R effect. Always keep in mind any group in which atom directly attached to the ring has a pi bond will show minus R effect, means it has electron withdrawing effect. It is an electron withdrawing group.
Yes.
Electron density on the ring decreases,
Yes.
so attack of the electrophile is decreased to some extent, and that's why third is
The least reactive.
yes, CH3CO group has electron withdrawing effect due to minus R, which is dominating,
Yes.
and that's why it third is less reactive than first. That means second is more reactive than first, because in benzene there is a hydrogen.
Yes.
Hydrogen is considered as neutral, it has no effect, zero effect,
Yes.
and we compare others with it. So any alkyl group has donating effect, and any group which has electron donating effect either by hyperconjugation, by plus I effect, or by plus R effect, anything. So in that case that becomes more reactive. So second is more reactive than first, and first is more reactive than third. So this is the order of reactivity. Second, because of releasing effect. So if means electron releasing groups are activating groups, they activate the ring towards electrophilic substitution reaction, because it will increase the electron density on the ring, so attack of the electrophile is facilitated. It becomes more than normal benzene. But in CH3CO group, which has electron withdrawing effect, it will decrease the electron density on the ring, and that's why electrophile attack on the ring is somewhat hindered, decreased as compared to normal benzene. Okay. Now Next is nucleophiles. So they are actually negatively charged, or if they are neutral, they should be electron rich.
Yes.
They should have unpaired electron pair so that they can attack on the electron deficient side. And they are also called Lewis bases because they have unshared pair, so they are able to donate electron pair, and that's why they are Lewis bases, or they are electron pair donors. For example, H negative, OH negative, X negative, Cn negative, N3 negative, they are all electron rich, and that's why they can attack on the electron deficient sites. Even neutral like H2O,
Hello.
yes. Yes, first I let you know what is the difference between base and nucleophile. So actually base has the ability or capability to attack on the hydrogen. Base abstract hydrogen from the compound. Means H plus from the compound. It will attack on H plus. And nucleophile, that will attack on carbon. See, they are Lewis bases
Yes.
as well as nucleophiles. So smaller the nucleophile, means smaller the ion, better the nucleophile. And if ion is bigger, that is better base than nucleophile. For example, if we have CH3O negative and CH3, CH3, CH3O negative. So if we compare them, first one is better nucleophile. Because it can easily attack at carbon because of its small size. But the tertiary butoxide ion, it is bigger ion.
Yes.
That's why it will not attack at the carbon, because carbon is tetrahedral, it is attached to 4 groups,
Yes.
which may be bulky. So that's why it is a better base. Got it?
Understood.
So if an ion or a molecule, neutral molecule, is a better nucleophile, that undergoes substitution reactions. That undergoes substitution reactions. Nucleophilic substitution reaction, SN reactions. But if it is a better base, it will undergo elimination reactions,
Okay.
like beta elimination reactions.
Understood.
Okay, so that is the basic difference between a Lewis base and nucleophile. Okay, so base जो है that will lead to elimination reactions,
Okay.
and nucleophile that will attack at carbon, and therefore it undergoes substitution reactions. Lewis base means, what do you mean by Lewis base?
The molecules which donate electrons.
Yes, Lewis base means which is dealing with electrons. Electron donating species,
Yes.
like Lewis base means electron donors.
Yes.
Otherwise, NaOH is also a base, but it is not a Lewis base because it will give OH negative ion. But if we have ammonia, you know, it can donate its lone pair,
Yes.
and that's why it is a Lewis base. Now, ambiphiles. So, ambiphiles behave as electrophile as well as nucleophile, both. So, H2O, ROH, they are of dual nature.
Okay.
So, alcohol and water, they are behaving as electrophiles as well as nucleophile, and that's why they are called ambiphiles. So, there are only two examples you can easily remember.
Yes.
Okay. And what are those donate H plus? H plus donors are protonic acids. So arrhenius acid as well as bronsted-lowry acid.
Yes.
But if it is electron acceptor like BF3, AlCl3, they are Lewis acids.
Yes.
Right. So now let us do few questions. First question is, which of the following is a false statement? First is, free radicals, carbonium ions and carbon ions, they are reaction intermediates. Is it true?
Yes.
So keep in mind, what are reaction intermediates? Which are formed within the reaction. They are neither reactant nor product, but they are formed in the intermediate steps. To explain its mechanism, we will draw them. So carbocations, carbanions, even free radicals. Carbocation means carbonium ion.
Yes.
Carbon ion means any
Negative charge.
negatively charged carbon atom. Any ion which has a negative carbon containing negative charge, and free radical
Low
which has one unpaired electron.
Yes.
Then come to carbene. It is also a reaction intermediate.
Yes.
Even there are more benzene, enamines, but they are not in our syllabus. But I have written this carbene because it is used in Raymond-Diamond reaction. That's why I kept it. Okay, next is reaction between methane and chlorine in the presence of sunlight proceeds via free radical. Is it true?
True, sir. Chain initiation, chain propagation, and chain termination.
Yes. So there is a trick. How do you know that this particular reaction is free radical, so you should keep in mind this word helper.
Okay.
So
What?
helper, H means heat or high temperature. So whenever we heat at high temperature any substance, any reaction which is taking place at very high temperature, that means it is a free radical reaction.
Okay.
Electrolysis, any reaction which takes place by electrolysis, electricity is used, so that is also free radical. Then any reaction in which light is used,
Oh,
see it is written methyl and chlorine in the presence of sunlight. Any reaction in which peroxide is used,
okay, sir. Like anti-Markov.
yes, any reaction in which electricity is used, and any reaction in which there is a radical initiator.
Okay.
So
Okay.
in
Our we use radical initiator also, sir.
yes, but in our case we have to remember light,
Yes.
peroxide, electrolysis, and if there is a high temperature. If there is a comparison between two reactions, one is at low temperature, other is at high temperature. So the temperature, if it is high, that means that reaction may be a free radical reaction.
Okay.
Okay, next is electronegative atom in the carbon.
False, sir.
Electronegative in the carbon chain produces plus I effect. You know, it will produce
Minus I.
minus I effect, because chlorine is like chlorine, it is electronegative atom, it withdraw electron from the chain, and therefore it will show minus I effect. It has minus I effect. Minus means electron withdrawing effect,
Yes.
plus means electron releasing effect. Now homolytic fission of carbon-carbon bonds gives free radicals.
True, sir.
So that means only C option is false.
False.
So what is homo, if you know then it's okay. Otherwise homolysis and other is
Hydrolysis.
hydrolysis. Homolysis means like peroxide. In case of peroxide, there is homolysis. Homolysis means if we have two atoms,
Yes.
then each atom gets its share. You know, when a bond is formed, one electron is shared by each. So if each atom gets its share back, you know, there is generation of free radical. So whenever there is homolysis, or we can say homolytic cleavage,
Yes.
homo means same, so homolytic cleavage or homolytic fission,
Yes.
all is same. Homolysis means, homo means same, lysis is always means breaking. Pyrolysis, breaking by heating.
Yes, sir. Electrolysis.
Electrolysis means breaking by electricity.
Yes.
So in this case we get this free radical.
Yes.
This is benzoyl peroxide. Each atom gets its share of electron and we get two free radicals. In hydrolysis, like we have A, B,
Yes. The electronegative atom takes the
we get carbocation and carbanion, or we can say any cation and anion, because more electronegative atom get both the electrons.
yes.
Like in this case, If it breaks like this, so we get carbocation and anion, Cl negative. And this is heterolysis or heterolytic cleavage or fission. Heterolysis, heterolytic cleavage or heterolytic fission. Next, what is the correct IUPAC name of this compound? Write its IUPAC name.
Yes.
Just write the IUPAC name of this compound.
So option B, because longest carbon chain is 10 carbons.
Okay, so we start numbering from this side because we should give lowest number to the double bond.
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So at 5 and 6 there are 2 ethyl groups.
Yes.
So 5, 6 diethyl. At 3 position there is 1 methyl group,
Yes.
3 methyl and dec, and double bond is between 4 and 5, so it is 4-ene. So it is 5, 6, it should be capital. 5, 6 diethyl, 3 methyl, dec, 4-ene. So B option is right. Okay. Hyperconjugative stabilities of tertiary butyl carbocation and 2-butene. One is carbocation. See, whenever we have carbocation, I am writing simple carbocation like this. So, in carbocation, carbon has one vacant p orbital.
Yes.
Because, carbon is 2s2, 2p2.
Yes.
So, when carbon is positively charged, one of the electron is removed from 2s because it is paired. So we get 3 unpaired electrons and 1 vacant p orbital. And these 3 form bond. See, 1, 2, 3. And 1 there is a vacant orbital, p orbital. So this sigma bond of H, that is alpha carbon,
Yes.
that will interact with empty p orbital, and that means sigma and empty p orbital. So obviously first option is correct, because in the second case there is sigma and sigma star, that is not true. Sigma p filled, wrong. P filled sigma star. And at the same time, in case of alkene, in case of alkene, it is like this. So in this case, what happened? Again, there is a sigma CH bond, and that will interact with pi star orbital of alkene. So sigma and pi star electron delocalization. In carbocation, it is sigma p empty, and in case of alkene, it is sigma of CH and pi star of alkene, not pi orbital, because this, this pi orbital is like this: one electron cloud above the plane, other is below the plane.
Yes.
But sigma star is like this, and that sigma star will interact with sigma bond.
Understood.
So it is sigma and p empty in case of carbocation. In case of alkene, it is sigma and pi star of alkene. So that is hyperconjugative stability. It is used for hyperconjugative stability, and this is called hyperconjugation, because alpha carbon is involved, and more is the number of alpha carbons, more is the stability of carbocation as well as alkene. Yes. Now tell me, the compound which gives most stable carbonium ion on dehydration.
So dehydration will be from alpha beta carbonides.
Actually, dehydration means removal of
What?
water. So, whenever dehydration takes place, carbonium ion is formed. Dehydration means removal of water. So, obviously, when water is formed, this OH will be removed.
Yes.
In acidic medium, this OH becomes OH2 positive. This becomes OH2 positive, and therefore this is removed.
Yes.
So when this is removed,
Sir, I think option D will be correct.
so there is a formation of carbocation.
Yes. Okay. Okay. Sir, but where did the hydrogen get taken from?
Because it is understood that whenever we have carbocation and we are talking about dehydration, it should be concentrated H2SO4. If we have ethanol, so ethanol undergo dehydration in the presence of concentrated H2SO4 at 443 Kelvin.
To give heat.
So we get ethene along with water.
Yes.
So what is the mechanism? First of all, this ethanol
Will get attacked by acidic hydrogen.
this concentrated H2SO4 give H plus ion,
Yes.
and therefore we get protonated alcohol.
Yes.
So when this protonated alcohol is formed, OH is a strong nucleophile, keep in mind.
Yes.
That's why it is a very poor leaving group.
Okay.
To make it a good leaving group, this acid will help.
Okay.
This acid will give H plus ion, and that H plus will attack at electron rich site, and which is oxygen. So this oxygen is attacked by H plus ion. So we get H2O positive, and H2O positive can be easily removed as water, and we get carbocation. And when this carbocation is formed, that H plus ion is removed from this CH3 and we get, it is like this CH3, this is H, electron pair comes here to satisfy the positive charge, and therefore H is removed as H plus. So in short, H plus ion first used in the first step is removed in the other step, and that's why a concentrated H2SO4 is a catalyst, and this is called catalytic dehydration, acid catalyzed dehydration. So overall carbocation is formed, OH is removed and we get carbocation.
Okay, so is this called alpha beta elimination?
This is beta elimination reaction,
Beta elimination.
because hydrogen is removed from beta carbon, so this is called beta elimination. And one more rule keep in mind, if we have now tell me, if I use concentrated H2SO4,
Yes.
what are the products formed and which one is the major product?
Sir, But-2-ene is formed 81% and But-1-ene is formed 19%.
Why?
What's it?
Why is it so?
Because the stability of alkenes, But-2-ene will have more alpha hydrogen surrounding the double bond system.
Which rule will decide it?
States that
Oh wow. So this is ZSEV or Sedgef rule, and this rule tells us that whenever this elimination takes place, poor becomes poorer. Poor becomes poorer means this is the carbon in which OH is attached, that is called alpha carbon, and next is beta carbon next to it. So beta hydrogen is removed from that carbon which has lesser number of hydrogens, means poor becomes poorer, मीन जिसमें कम हाइड्रोजन होंगे उस पे और कम हो जाए. सो मेजर प्रोडक्ट इज this one. But-2-ene is major product, though minor product is also formed, but to little extent. What is the percentage?
81 and 19, sir. I think.
But that is not asked कि how much the percentage of But-2-ene and But-1-ene, but question is like which one is the major product?
Yes.
So it is But-2-ene, and why? Because of Sedgef rule, and at the same time But-2-ene is more stable.
Yes.
Because it has 6 alpha hydrogens, and in minor case But-1-ene there are only 2 alpha hydrogens, and because of hyperconjugation But-2-ene is more stable than But-1-ene. And if it is question is like this, how many total compounds are formed including isomers, including stereoisomers? then how many products are formed?
Then,
There are three.
yes, so this is a trans isomer of the major.
Yes, because but2-ene can exist as cis and trans.
Yes.
So this is trans and cis and but1-ene. So total 3 isomers are 3 compounds. Yes. Select the correct order of basic nature.
So we know alkynes are most acidic. So we will be least basic. I think option is
Option. Okay. So see, first of all, what we do, we write its acid. See, we have ethane, ethene, ethine, and water. So, in first case, there is CH bond and carbon is sp3 hybridized. In second case, we have CH bond and carbon is sp2 hybridized. In third case, there is again a CH bond and carbon is sp hybridized. And in the last case, we have OH bond. So if we compare, which one will give H plus ion most easily? Obviously OH,
yes, sir.
because oxygen is more electronegative. So oxygen withdraw electrons from hydrogen and therefore OH bond is most polar.
Yes.
And if we compare sp3, sp2 and sp hybridized carbons,
Correct.
see, if we see the electronegativities, oxygen is most electronegative.
Yes.
Carbon, which carbon is more electronegative than the other?
sp hybridized.
sp hybridized carbon is more electronegative than sp2 and sp2 is more electronegative than sp3.
Yes.
And then there is hydrogen. So least electronegativity difference is between sp3 hybridized carbon and hydrogen,
Yes.
and that's why it is almost non-polar or least polar, we can say. So order is for polarity is like this, and so is the order of acidic strength.
Yes.
So stronger acid
Gives weaker base.
has weak or give weak conjugate base.
So you are considering water as an acid right now, sir?
Yes. Otherwise, all of them are not at all acids.
Yes.
But we are comparing them on their acidic strength. If they are acting as acid, which one is strongest? So stronger acid has weak conjugate base, and therefore H2O is strongest among these four, and therefore H2O, if it is taken as strong acid, OH negative is,
Weak base.
yes, out of these it is strongest, so it is weakest base.
Okay.
That's why A option is correct. On the other line, if we consider only Lewis character,
Yes.
so oxygen is most electronegative.
Yes.
So oxygen will not give electrons easily.
Yes.
That's why OH negative is weakest base. But if we compare these carbons, which one hold the electrons tightly? Which is most electronegative? So sp hybridized carbon is most electronegative, and
Yes.
that's why it holds the electrons, cannot give electrons.
Yes.
So which one give easily? sp3 hybridized carbon,
Yes.
because that is least electronegative, and that's why we can explain it like that as well.
Understood.
And this rule is in,
Bronsted-Lowry.
it is from Bronsted-Lowry concept. Yes, arrange in order of decreasing trend of electrophilic substitution reaction.
Okay, sir. Aluminium chloride means, sir, benzene and NH2Cl on top of it.
NH3 positive, Cl negative.
Just a second, sir. Option, just option C, sir.
Mm. Okay, good. So first is chlorobenzene.
Yes. Deactivating.
Second is benzene. Other is anilinium chloride. And last one is toluene. So if we compare these four, chloro, what is the nature of chloro? Is it electron withdrawing or electron releasing?
It is electron withdrawing, sir.
Why? It has lone pair. If it has lone pair,
Okay.
it will has plus R effect,
Yes.
and at the same time minus I effect. So it is electron releasing due to plus R effect,
Yes.
and electron withdrawing due to
Minus.
minus I. But keep in mind, halogens are exceptions. There are special case where resonance decides their orientation.
Yes.
In halogens, resonance, only in halogens, resonance decides orientation, and that's why it is ortho-para directing.
Yes.
And resonance and inductive effect decides its reactivity.
Yeah. Yes.
So due to minus I effect, it is deactivating group.
Yes.
So it is less.
For all halogens.
Yes. Fluorine is somewhat least in this case, because fluorine and carbon is on the same orbit, means carbon and fluorine, they involve 2p2p. So
Yes.
their plus R effect and minus I effect is almost balanced. But in general we can say that inductive effect decides its reactivity, and that's why chloro group is deactivated due to minus I effect. So first is less reactive than second,
Yes.
or we can say second is more reactive than first. Now, if we see the fourth one,
Yes.
you know, there is a methyl group. Methyl group has plus I effect,
Yes.
and at the same time hyperconjugation.
Yes.
That's why it is activating group. So it will increase the reactivity. So fourth is more reactive. Fourth is more reactive than second. So see, fourth is more reactive than second. Second is more reactive than first. And wait. Yes, chlorobenzene, and then it is anilinium chloride, because here it is nitrogen, in this case it is chlorine. So chlorine, yes. Tell me.
What's it?
It in NH3 plus, it will show only minus I effect,
Yes.
and chlorine, but in nitrogen, you know, it is already attached to 3 hydrogens,
Yes.
but chlorine is alone. So chlorine is considered more electron withdrawing than NH3 positive Cl negative,
Yes.
and therefore its order is fourth is most, and there is only one option where fourth is most reactive.
Yes.
So there is no need to think beyond it, because you know there is only one electron releasing group,
Yes.
and that's why it is most reactive. In other cases it is fourth, means it is very simple question. If you know that CH3 is electron releasing group, activating group, it should be more reactive than benzene, then answer is C only.
Understood.
Yes. In 2,4,6 trinitro-iodobenzene, there are 3 CN groups.
What's it? 3 CN bonds.
CN bonds, there are 3 CN bonds.
Okay.
So they are labeled as A, B, and C. So what is the order of bond length?
Okay. Just a second. Yes. Sir, option B. Iodine will reduce. Okay, no, it won't. It will reduce electron density on
Yes.
A and E more than it will on C.
Yes. So iodine, you know, it has minus I effect,
Yes.
and this minus I effect is more pronounced at ortho position
Yes.
than at para position.
Yes.
And in NO2, all their electron withdrawing groups minus R effect. Therefore, resonance is more at para position than at ortho positions. So that means CN double bond character is more in para than in ortho.
Understood.
So that's why bond length is least in C. AB, there is the same effect of iodine, on both of them. That's why A and B are of equal length and C is smaller because of greater resonance at para position.
Understood. So where are these questions from?
These are questions taken from Chemistry Today book.
So like what level are these questions?
11, 12.
Oh,
Yes. Yes. Molecules that are not superimposable on their mirror images, they are chiral, right? They are enantiomers,
yes.
they are optically active. Chiral means which are optically active. So what is the criteria for optical activity?
Chiral centers.
No. All chiral molecules have chiral center. That's not true. Because there are few like allene. This is called allene. Means any cumulative alkene, these are called cumulative alkenes. Alkenes, see, there are three types of alkenes. One is like this, where double bonds are separated by more than one bond. There is more than one single bond between two double bonds. Such dienes are called isolated dienes. The alkene dienes in which there is only a single bond between double bonds, they are called conjugated dienes, which is the condition for resonance.
Yes.
And other one is when double bonds are adjacent.
Oh, yes.
So they are called cumulative dienes. And whenever there are cumulative dienes with even number of carbons, cumulative dienes with even number of carbon atoms, they are always
Optically active.
have dissymmetry. Actually, dissymmetry is the condition for chirality. Okay? Dissymmetry, like say we have these two hands, right? If we see in the mirror image, they looks like this.
Yes.
So when we put hand together, they are non-superimposable.
Yes.
So that non-superimposability is due to dissymmetry. It is due to
Yes, sir.
dissymmetry. Chiral center is one of the condition. If there is one chiral center, that is always optically active.
Yes.
But sometime, if there are two chiral centers, then
Internal compensations.
yes, sometime there is internal compensation, like we have compound sometime like this. There is a plane of symmetry.
Yes.
So any compound which has no plane of symmetry or center of symmetry, they are always dissymmetric and are optically active. So
This one will have mesomers that don't have friendship.
yes, this is meso compound, and because its mirror image is superimposable. But if we have this structure, and the mirror image is non-superimposed, means it has three isomers. If it is one is D, other is L, they are called enantiomers.
Yes.
Oh. Intramolecular hydrogen bonding is present in.
Yes.
There is only one option where intramolecular hydrogen bonding is present.
Yes.
It should be at alpha, at ortho position. This is orthonitrophenol, and because of intramolecular hydrogen bonding, boiling point decreases.
Yes.
Because it is stable in its own, so it becomes isolated.
It will increase, sir.
But
Boiling point.
in intermolecular hydrogen bonding, boiling point increases.
Intermolecular.
In intramolecular, here in this case boiling point increases. That's why to separate orthonitrophenol and paranitrophenol, we use steam distillation. So in steam distillation, orthonitrophenol is steam volatile, means it will form vapor with steam, but paranitrophenol is steam non-volatile. Okay. There are two statements. One is boiling point of three isomeric pentanes. Follow the order. Normal pentane 1, 2, 3, 4, 5. Other is isopentane, and last one is neopentane. So boiling point of normal pentane is greater than isopentane, which in turn greater than neopentane. So why is it so?
Because of surface area.
Because when branching increases,
Boiling point decreases.
Surface area decreases, and therefore interaction decreases, so boiling point decreases. So see, statement 1 is true.
Yes.
Correct. But second, when branching increases, molecule attains the shape of sphere, right? See, it becomes almost,
Yes, sir, it approaches a sphere.
and this results in smaller surface area for contact, and due to which intermolecular forces between the spherical molecules are weak, and therefore lowering the boiling point. So both the statements are correct,
Yes.
and this statement 2 is correct explanation of statement 1, right?
Yes.
But it is not given simple. Both statement 1 and 2 are correct.
Okay, this is not reason assertion. It was a statement.
Yes. सर 5 मिनट में कॉल करता हूँ. ठीक हाँ बेटा. Yes.
Yes, sir, option D.
Okay. Most stable carbocation among the following is, so see, this one is secondary carbocation.
Yes.
This one is again secondary.
Yes.
This one is primary,
Yes.
and this one is tertiary. So keep in mind, whenever we have these carbocations, obviously tertiary carbocation is more stable than secondary. Secondary is more stable than primary. This is order of stability of carbocations.
Yes.
But out of A and B, which one is more stable?
Out of B is more stable.
Very good. Because say there are 5 alpha hydrogens,
Yes.
and in this case there are only 3 alpha hydrogens.
Okay.
So hyperconjugation, because if we compare inductive effect and hyperconjugation, then hyperconjugation is dominating.
Yes.
That's why B is more stable than A. But out of these four, D is more stable because there are total 2 plus 2 plus 3, 7 alpha hydrogens. In this case, there is only one alpha hydrogen.
Yes.
So that's why D is most stable. Okay, this is
Different chapter.
Okay. Correct acidity order of phenol, 4-hydroxybenzaldehyde and 3-hydroxybenzaldehyde. Phenol.
So 4 means para and 3 means meta.
Yes, it is para. Sorry, CH. CHO means C double bond OH.
Yes.
So
It has minus R effect, right?
CHO group has minus R effect and minus I effect.
Yes.
But at meta position there is no resonance. Resonance takes place at ortho and para only.
Okay.
So if we compare 2 and 3, in second and third, in both cases CHO is electron withdrawing,
Yes.
but because of different effects. In second case, it is electron withdrawing due to minus R effect as well as minus I effect.
Yes.
But in third case, it is electron withdrawing due to minus I effect only, because resonance takes place at ortho and para positions only.
Yes.
So CHO in this case, it is meta to OH,
Yes.
and that's why there is no resonance. So resonance is dominating over inductive effect.
Yes.
So, and in this case both are on the same direction.
Yes.
Therefore it is more electron withdrawing. Here CHO is more electron withdrawing, and here it is less electron withdrawing. And electron withdrawing group increases the acidic strength.
Yes.
So that's why most acidic is second. And yes.
The third option, I guess also the minus I group is also closer to the OH one.
Yes, but when we have resonance and inductive both,
Yes.
resonance is always dominating over inductive effect. No doubt minus I effect of meta CHO is more than minus I effect of para. But at para position there is minus R effect as well, and that is dominating over inductive. That's why, because at para position CHO has minus R effect, it is most electron withdrawing group. And keep in mind, how do we decide it is minus R? Because carbon, the atom which is directly attached to the ring, has a pi bond. That's why it has minus R effect, right? Therefore most acidic is second, then third, and least acidic is first, because electron withdrawing groups increases acidic strength. Okay, I hope let it be, because it is already too late. Okay,
Okay, sir.
so we will continue this topic tomorrow as well.
Okay, sir. Is there any today's PDF?
Yes, yes.
Thank you, sir. Good night.
Good. Chair, POs and COs absent means Chair, what it means? PO and COs means? Achha, okay, plane of symmetry and center of symmetry, got it. Okay, okay, okay. Okay, so we will continue this journey. Yes, yes. At tomorrow at 8 o'clock. Yes, yes, I got it. So see you tomorrow at 8 p.m. Okay, so happy learning. Bye bye.